So that's what I told you, like that movie review data set, whatever I have shown you, na, that it was released in 2004 by Cornell University. So that data set we are going to use for our application. And first of all, what is that data set? That data set is about movie reviews. So over the period of a year, there are a lot of movies which came and right, like which are coming. So review polarity data set consists of 2000 movie reviews, in which 1000 movie reviews are of positive sentiment. What do you mean by positive sentiment? Those reviews which gave a movie more than 3.5 star on the scale of 1 to 5, 0 to 5. So all the movies which have reviews more than 3.5 star, 3.5 or 3 more than 3.5 star, those are definitely good movies. So those movies are considered on positive sentiment, and again 1000 other movies which are considered as negative sentiment, because they had their movie reviews rating 2.5 or below it. Got it? So in this
Mhm.
particular folder, you will find that there are two folders. One is neg, which is negative, and one is pos, which is positive. You will
Positive.
find 1000 reviews. And like this positive one, you can open it also. You can see what is written there. So you will find that this is a review which they have written, okay, in positive form. Like this is a positive review. If you read this, their characters are real people, neither is perfect, but rather of both of the leads are from misguided individual. I mean, this is like the plot they are talking about. But
Mhm.
even if you will, what's amazing about election is the word of that. So if you will read the reviews like this, na, they are the positive reviews of movies, okay. Similarly, the negative ones are negative, okay. Like it's a beautiful film by director continuing to challenge himself year after year, right? So these are like positive movies, positive reviews, sorry. And similarly, if you will read these, they will be negative. Now, our what is our target? Our target is, can we build some model onto this from this data, positive and negative, so that for any given review, I can say that whether this is a positive sentiment or a negative sentiment. It's a simple binary classification problem, you know. You have 1000 positive reviews, you have 1000 negative reviews. Can we build some model which can say for the other movies, for the unseen next upcoming movies, just by reading the reviews, it can say that whether it's a good movie or a bad. What is the sentiment? I mean, is it the positive sentiment with which author is writing, or it's a negative sentiment, right? So, so that is what I am saying. Like this is the objective, to build a model which can detect sentiment from text. Good enough? You
So
got
these are multiple movies or a single movies review.
multiple. It may happen that for one movie there will be two, three reviews, because different people give
Mhm.
review to movies. But all these 2000 reviews are, I mean, it's not like they are biased. It's not like they have kept one good movie and one bad movie and they have taken all the reviews. All the reviews are in fact different for different movies there. Okay.
So there is a chance that one review can As content of two movies, review of two movies.
No, no, no. See, at this site like IMDb or Rotten Tomatoes, if you see,
Yes.
if you watch movies and if you read the critics, they
Mm-hmm.
on IMDb or on Rotten Tomatoes, like a guy will review about only one movie, no, in one comment.
Mm-hmm.
So the reviews are movie specific. For one particular movie, lots of people will write their whole paragraph that how did they feel and what do they think of the reviews. It's not like they will be talking about two movies.
Yes. Yes.
Okay,
Okay. Okay.
so fine. So I hope you understood the database data set on which we will be working. Now coming to what, how do you deal with this? This is a problem of uh, what do we say? Text. This is a text problem, right?
Yes.
Yeah. This is a text classification problem.
Test. Test. Test classification.
Text classification. Now, where this is like positive sentiment, this is negative sentiment. Now, what is the most common way by which you can say that whether the movie review is positive or negative? We are not talking about the average movies here. That's what I said. Like all these 2000 movie reviews has been taken such that the 1000 movie reviews in positive folder are of those reviews which gave them 3.5 star or more than that out of 5, right? And the negative ones
Okay.
are those for which the movie review has given 2.5 or below that. So basically we are not considering 2.5 to 3.5. Between that we are not considering. My question is, you forget about neighbors, you forget about SVM, you forget about machine learning. What is the best way? How do we human decide that what is the sentiment? As a human being, when you are reading one of these reviews, how do you decide that this is a positive sentiment or a negative sentiment? So we basically decide it by words. So people came up with this idea. Okay, see, how do we decide whether it is positive or negative? Just by words. So what you do, you make a huge list, maybe 100 word or 1000 words, which shows positive attitude, positive thing, right?
Okay.
That's what I'm saying. Make a list of words, say 50 words or 100 words, which are positive sentiment words. And similarly make 50 or 100 words which are negative sentiment words. Okay.
Okay.
And then
Okay.
whenever a review is coming, you just check that those words are more reliably coming in first or I mean positive side or negative side. So if the reviews have the positive word, it will definitely match the positive side. If the reviews have negative review, it will definitely go to the negative side, right?
Most of the negative word, maybe a negative review.
Maybe.
A negative review
Yeah,
for
yeah,
that
yeah.
movie.
Yeah. So that is like words like it was worst, humiliating, boring, awful. Maybe such kind of words if are coming in a critic review, it means that the review is bad. But now the problem is how do you do this searching and all, right? I mean, for a particular review, you will go word by word, you will check your dictionary, whole dictionary which shows positive sentiment. You will go word by word and then you will see the matching and then maybe you will find that okay, more, I mean, then you will find that okay, this is matching more with positive or maybe negative. So it's very time taking, right? And it is not even fixed. Like how many words do you include in saying that this is positive sentiment? How many words do you include saying that it is negative sentiment? And then also the timing was is a big issue, right? Like if you have a review like this, which has how many? Like if you see this, any of this review, it will have like a lot of words, right? Like maybe 20 lines, so 20 words, so 400 words, right? So all these words you have to then check with the dictionary. And for so many reviews, it will be time taking. That's just one statement I want to make. And then that is also uh, not definitely it's not definite that if it is not matching with the words of positive, then it is negative only, or if it is not matching with negative, it is positive only. The definite, it is not definite because sometimes the reviewers or any human being, we write in a different way, right? Like I will say, uh, like for a positive review, you can say that uh, for a movie which is positive, maybe you can say that the movie was not boring at all.
Mhm.
Okay, if this kind of statement you make, now boring word is coming. Why? Because the author feels that movie was not boring, so he wrote movie is not boring. But the boring word lies to the negative side, right? It it
Yeah,
it falls in the negative sentiment. So the machine will be trapped. Like it will get it in a wrong way. That
but we put not
we
keyword.
huh?
But we put not keyword before that
Yeah, so
boring word.
then yeah, definitely. So then you have another set of problem, or you can say then there is another set of information that you want to keep, and that is you need to keep the pair like not boring, not good. Now if it is a movie
Mm.
is not good, yeah. So good is coming. It means it is a positive side, but it is coming with a negation. So then you have to keep the information like this also. That maybe uh, I mean maybe the word is positive, but it has been said in a negative way because with not it was used. So you have to keep that not information also, right? So
Yeah.
so overall, what I am trying to say is instead of conventionally making a dictionary of positive and negative words and all and doing all those stuff, what people came up with that no, we will use some features. We will convert these texts into some vectors. Maths, they utilize mathematical fundas, and they said that whatever text you give, I will convert it into through my neural network or through any model. I am saying like neighbors or whatever it is. I will convert those reviews, the whole file, text file into some vector. Okay, so mathematical vector, and then you see. I mean, then you model it such that you can say that okay, this is positive, this is negative. So when you convert a thing into a vector, long vector, the whole text file, then probably you can keep those information also like not boring and all. So these kind of information maybe you can keep. with a vector kind of thing, where if I say, so this is a long vector, where all the positive sentiments, oh sorry, not positive sentiments, or the review which was of positive sentiment, that whole review, all the words, like 400 words were there, so all the words are now get converted into some values. Some values. You get it? All the words of, like, let us take an example. See, all the words will be converted into something like this. Okay, a word vector. And so, what I am offering here, can you think of what I am trying to say? I am trying to say, if you have 1,000 files for positive, and similarly you have 1,000 files for negative. Now what I am trying to say is, for 1,000 files for positive and 1,000 files for negative, you see, for all the 1,000 files, 1,000 into, let's say, we will take 500. So it will be a 500 long vector, or let's say a maximum of say 5,000. So for each review, for each file basically, I am taking 5,000 vector size, where whatever words had come in this file, say 400 words have come. So those words will get some value, 1 or 2 or whatever, 1 like this, and the rest all will be 0. Rest all will be 0. So
For positive sentiments,
yes,
for positive word.
so similarly we will do it for negative also. For all the 1,000 files, we will make a vector. Let's say a vector of 5,000 values. So for first file, all the words, for that's what I'm saying, for the first file, all the words which were present in the file, they will come up at some position, they will come up as 1. Rest, other whole thing will be 0 for that file. Whatever words are coming in the, so here you are keeping the references also somewhere, like not good or something like that, right?
Okay.
So now I will tell you how do they do this, okay? So first of all, the first step is, see, first step. First step is making dictionary. Making dictionary. Now what is this making dictionary? You had 2,000 movie reviews. You combine all the reviews, you read all the things in one list, and you put a counter there. What I am trying to say is, you take all these 2,000 movie reviews, put a counter and make a dictionary. Now what is this dictionary? Dictionary is all the unique words. with their frequency. All the unique words. So basically you have combined all your data set, 1000, 2000, everything, right? And now you are making a dictionary that which word has been most spoken, right? So so it depends upon basically the counter, right? So if I say that and has come 100 times in all these 2000 movie review, then has come say 50 times, then amazing, then good, then some negative words and all like that. These are like there. So this is like making a dictionary of unique words. And you take it, like
Okay.
you say that I will take top to 20,000 words. I mean, you can you imagine with this 2000 movie reviews, how many unique words will be there? It will be huge.
Mm,
It
huge.
will be around 20,000 or maybe 30,000.
Mm,
Okay.
yes.
So, so unique word you capture, and that is your dictionary size, like 20,000 maybe your dictionary size. Now what they do is, once they have made the dictionary, the second thing is like feature vector generation. So what they will do, that you you have a dictionary of 5,000, sorry, top 20,000 words, right? You have a something like one dimensional thing like this, no?
Mm-hmm.
So 25,000 dimension.
25,000.
So you will put all 25,000 zero first. Now just see, just take one by one all the positive files, all the 1,000 positive files, just take, and for each file I will be generating such row, like 20,000 into 1. So for each row, whatever where see, there are 20,000 words you have taken, top 20,000. So whatever words are there in this 20,000, you just mark it 1 or mark it like this. Right. So whenever a word will come up, you will put it somewhere in this 5,000, 25,000, dimension. So 25,000 dimension it is, and only those words carry one or two or three which are related, right? So 20,000 you have vector size, but only those words will be activated where uh, which were in that particular file, and you will do it for all the 1,000 files. So ultimately, what you are going to get, 1,000 files of positive into 25,000 dimensions. Okay, so same case with negative, 1,000 file with 25,000 maybe words. So this is negative. So each of these rows, they are of like 25,000 dimensions, and only that where those indexes turn on where you find the words. So like this you
Okay, okay.
will go, and once these two matrices, feature vector matrices, are completed for 1,000 positive and 1,000 negative, then you pass it through say SVM or say naive Bayes. And you can calculate the accuracy by doing some cross validation, like 10% of data you take for testing and rest you take it for training. So like train test, that cross validation thing will give you 100% accuracy. I mean that train test will give you 100%, I mean, coverage. Right? We have discussed this a lot, right? K cross fold validation, where
Yes, yes, yes.
yeah, where you train on 90% and keep 10%. Then next time train on,
Another set of
yeah,
uh,
yeah.
90% and another set of 10%.
What? Come again?
Okay. Another set of 90,
Yeah, yeah, yeah.
90% of data and
Yeah.
another set of 10% data.
Another set of 10%, like that maybe you can also do, and you can find what is the accuracy on 2000 movie reviews. You can also, in fact, you can go to any IMDb or a Rotten Tomato site, just copy a review. Okay, I am saying copy a review means whatever people have written, say more than 3.5 or less than 1.5,
Hmm.
right? So
Okay.
for such kind of movie, you can also grab from IMDb or Rotten Tomatoes, and then you can test it on actually whether it is giving you
Okay.
positive sentiment or negative sentiment. The movie we watched, right?
Okay. Yeah. So how it is helpful for a rating out of 3 out of 5 or 4 out of 5?
How it is?
What- How it is converted in the rating
Stars? No,
like
no, no, no. See, we are,
for
our problem is not to convert them into stars. That
okay.
star rating and all, that is a little different thing altogether. Our
Okay.
purpose here is to tell whether I mean, whatever is written, reviews or whatever, that, so that you can tell at least what is, if it is positive or negative sentiment.
Okay.
Okay. Okay. So our motive is to say positive or negative. Now, how we model our this uh, 2000 files polarity data set, that depends upon you. What you have to give, I will give you a text file and you have to tell whether it is positive sentiment or negative sentiment. Good enough?
Okay. Okay.
Okay, so that is one thing. Now I will now we will see the how in Python they have tried to do it. Okay, see this is the code. Just wait, I will. Yeah, so I just uncommented some code and commented something. See, so this was the root, isn't it?
Yes. Yes.
This one. My code is also in the same directory. So what is happening here? I am passing the root directory to make dictionary first. I told you, initially the whole dictionary is made. So this is a make dictionary function. Okay.
Okay.
Now what is happening here? I am getting all the files So actually the thing is like here I have written it in the naming convention of the variables are not good because I'm using email because there is another project like this where you were that was on this uh, email spam filter. So that was something other thing that whether the work and all whatever it is that is like related to your email basically whether it is of positive sentiment or a negative. It means whether it is a ham or a spam. So there are spam mails and there are legitimate mails which are also known as ham mails. So that
So
thing
the
is
same logic is applied for
same logic is applied
uh,
exactly
for
for ham versus spam also.
spam.
Yeah, legitimate
Okay.
mail or uh, this fraud mail. So same logic is applied. So that is why the whole definition I have kept the same. So even the variable names are like that. But what actually
Okay.
is going on? See, I have passed here what text send token. This will go here, and then see for f in O. So basically, all the directories I am taking here, whatever things are there in root dir, right? So it will automatically run some root dir that is text send token, whatever it is, and from there it will list the pos and neg folder, and this is a like
Hmm.
directory. Okay, it will contain this email dirs will nothing contain nothing but this positive and negative. Now for all such directories, what it is said that you just list that directory now and tell me all the mails. Okay, so this is again another
Okay.
thing that all your mail you are taking by listing down your uh, directory, maybe pause directory. Okay, and what we are doing, see, for each mail, for each review, basically we are opening it for line in M. Basically, we are splitting it each line into words, and then these words are counted and like given to all words. All words is an empty list where I can keep on adding, all the words which are there.
Okay. Okay.
Okay, so like you see for line in M, so I am splitting the whole line into words, and all words is equal to words. So basically, these words are getting copied into all words every time.
Okay.
Okay,
Yeah.
so and then see then when you keep all the words in the 2000 files or 1000 review files whatever, when you keep all the words you will need a counter. So you pass this through a counter, and the counter will give you the exact uh, thing that okay, this particular word has like almost 100% accuracy, huh? Or whatever it. I mean this. So like that you can say that this dictionary has been made. Even actually, what I will do, yeah, I will show you how this dictionary looks like. Okay,
Okay.
Can you see this?
Okay.
These are like it actually Python has dotted it, but these are like words. See, these are like words, right? So the has come how many times can you say?
76,000.
Hanging has come so many how many times? 48, right?
48 times.
Screaming has come 48 number of times. The and of has come so many. And what is this frequency that which I was talking? This frequency is like how many number of times this word has occurred and where.
Okay.
So whole 2000 files on all 2000 files off has occurred 33,000 times, the has occurred 76,000 times. Okay, so this is
Okay.
how a dictionary looks like.
And dot 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 is there are some words.
Yeah, yeah. I will show you in fact.
Okay. Okay.
Just wait. Huh?
Okay.
Just wait. Huh? Yeah. Can you see this? I have printed the first 20 words of this dictionary.
Okay.
This,
Top 20.
yeah, top 20. You see the maybe the counts have been decreasing right away, right? And
Hmm.
let me tell you, this dictionary will have, as I have chosen here, 2500. So whatever dictionary you have, whatever things you have done, and whatever words you have collected, the most frequent 2500 will be retained. You see, if I do it 200, can you see this? These are the words. And even this is
Okay.
nothing, this is just 200, man. There are 2500 words like this. Let's say I suppose say 2000. So when you give it more, it will just do dot 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 and it will, just eat away the
Yeah.
word. And so it will go like this.
Yes. Yes.
Okay, okay. So dictionary you understood now what it creates?
Yes. Yes. The words and their appearance in their file.
Hmm?
The words and their appearance in the
Yes, yes,
file.
yes. The frequency top 2500.
Okay.
Now the second thing which we do is Yeah. So the second thing which you will do is no. So yeah, this dictionary we are using here. No?
Mhm.
Mm, extract feature. Okay, okay, I got it. Yeah, now there is no error. This dictionary is also there. So see, the first step was to make dictionary. That dictionary I have made of 2500 or 25,000. No, 2500 most common words. Okay. Now we will extract some features. So this dictionary was like a background thing, right? All the 2000 data points, the text files have been mixed. Okay. But now we will extract feature like sentiment wise. We are now extracting features for the positive thing and again the feature for the negative thing. Okay. So that feature
Okay.
extraction we have to do like this. And this particular code of feature extraction is nothing but with the thing which I told you. Go to each review. You have a long vector of 2500 thing, 2500 words or 25 whatever it is, 25,000 words maybe. Now what you have to do is 25,000 words you have now for each vector. This is only for positive I am saying. For each vector, just read that first article wherever at whatever. See, this 25,000 words are like lying in a ascending order, right? So what I am saying is, or in this feature vector, you will whatever word will come in that file for that file you will keep those things as something and the rest other is like zero. You may say that 2, 3, 1, why these values, where from these values are coming.
Yes.
But that's what I'm saying. These are the indexes. Like you saw, no, 25,000 words were like this in decreasing order.
Yes. Yes.
But these places are the words which are there in this file. Now again you take another review. All the words you put something and rest zero. Whenever I like whenever I read again a movie review, I will write something like this. You read the movie review, you take out the words, those words, whatever index they are, just put it there, 1, 2, whatever it is, and that's your vector, feature vector basically.
So two, three, threes indicate what? It's
Yeah, yeah.
index of that number.
What?
Index of that number.
No, no,
Sorry, word. Sorry.
index to 25,000 is implicitly maintained. Na? From 1 to
Yes.
25,000 each index has been given a letter.
Yes.
Right, all those 1 to 25,000 you saw, na, it was in decreasing order. So
Yes. Yes.
Yeah, so that's what, like, in decreasing order, whatever words we have arranged them, and that is why, you are getting this one and all for all the words which are there in that list.
So we give the index to that word, one, two, three, four, five.
No, no, we give, I will tell
No,
you, we give count to it.
count. Okay.
So suppose
Okay.
in first review, good came three times. How many times?
Okay. Three times.
Three times. So wherever will be the index of good, na? So good in this 25,000 dictionary, so good is
Mhm.
at 191st position. So I will go to
Yes.
191st position here, maybe,
Hmm. Hmm.
and there I will keep it 3. Why? Because that particular word has come up 3 times in the same file. So that is the count which is put there.
Okay. It is count of the word.
Count of the word in that particular file only. How many times it has occurred in that particular file only.
Okay. In one file.
In just in one
Okay.
file. Because you are making only one vector out of it, na?
Yes. Yes.
Like that you have to make 1,000 vectors for
Yes.
for positive. And same stuff for negative also.
So this is 25,000 into 1,000 vector.
Yes, this whole matrix will be 1,000 files into
Files.
25,000
25,000
vectors.
vectors.
This 25,000 vector is nothing but the whole dictionary. I mean the indexes of dictionary, and wherever the word is coming, you are just flagging how many times it has come in that particular file.
So one line is indicate one file. Is it like that?
Yes, one vector, one
And
row is indicating one file.
one file. Okay.
Okay. So this whole concept is put into here, extract features. Again, I am passing the root directory. So what was the metric size?
1,000 into 25,000.
Right, 1,000 into 20. So the same thing I am feature vector matrix I am making. How many?
2,000.
This was actually not 25,000 words. This is 2,500 words only. The most frequent
Okay.
2,500. Okay. So you see
Okay.
how my feature vector matrix I am making now. What size I am making? Like we recently make
The
2,000 into 2,500. So why
2,000.
is it like this? Because 1,000 for a happy and 1,000 for
Negative
sad.
something.
I mean negative. 1,000 for positive. When the reviewers are, I mean, good to go about the movies, happy about the movie. And when you are negative, I mean, when you see the negative emotion, it means the movie is not maybe uh, it's very bad, right? So it's like negative. So for that 1,000 and
Okay.
this good and bad you mix and it will become 2,000 into 2,500. All you have to do is to just put the count, the just put the, I mean, count of that word in that particular file. How many times it has occurred.
Okay.
So like that, the same stuff if you will see. For all the dictionary I am enumerating and see I am opening each review, going line by line. splitting all the words, and for each word in all in this whole, for each word in the file, whatever long file is, for each word in the whole file, you search in dictionary first, you enumerate in dictionary also, and find out when the word is matching in the dictionary, right? So wherever the word is matching, like the word and the dictionary, they like they matched, right? So what we do is, in that feature vector matrix, we will, for that particular words, how many times it has come in that file, which is basically all words, how many count it has come, that will be stored. Like that, I mean, all for all the 2000 file, it will be stored like this one. You are doing all words dot count word, so it means like uh, for that particular word, you count that how many times it has come in the file, and that you then put it into feature vector matrix. Good
Okay.
enough?
But how it is identify if the word is positive or negative sentiment?
No, no. I am right now only making feature vector matrix
Okay.
that is of 2000 files. I am extracting the features only. I have not modeled yet.
Okay. Okay.
I have taken one matrix. It's instead of taking two different matrices, I just took one matrix where I am keeping all the positive as well as negative, like 1000 positive, maybe 1000 negative, right?
Okay.
And you will be surprised to know this kind of vector, you know, this the vector which we are making, like the 2500 dictionary size, and then at whatever position you feel like, maybe so I mean, you can do that, and you can then further model it through naive Bayes or SVM. So this extract feature, you understood or not?
Yes.
Like feature matrix, they are taking 2000, 1000 positive and
Mm.
1000 negative. And then for each of these, for say for email DIRs, in email DIRs, like this is like uh, for the positive, say, and then it will go for negative. For each word, it will find it in dictionary where what is the index, and there it will put the count, how many times it has come in that particular file. So
Okay.
what I was telling, that this whole vector of 2500 dimension, where each index represents the count of that particular word in the dictionary. So it represents the count, that how many times it has come in that particular file. This particular vector only is known, is a very famous vector which you will uh, hear, or maybe you will read some in text analytics. Like this is called as bag of words model. Bag of words model.
Bag of
Bag of word features.
words.
Also,
Words.
it is sometimes called as word count vector. Word count
Word count vector.
vector. So these two names are basically this feature only. For all the files, you keep like maybe for all the file you keep 2500 dictionary indexes, and at those indexes just put the count which has come in the file. Got it. So that this I just wanted to tell you that this is the feature which we. And we are writing a code like from scratch here, right? We are not using any sklearn or something for this feature extraction. Good enough.
Yes, yes.
Now, once you extract the features, and see, you have also the labels. So 0 to 1000 it's 0 positive maybe, and 1000 to 2000 it's 1 negative, right? Now once you have done
Yeah.
this, you will directly come to now stratified K4, the same feature vector matrix of this 2000, I mean into 2500. It will be split into maybe 90-10, because you are using stratified K crossfold, right? So
Yeah.
yeah, what I will do probably I will get this feature vector matrix and all from here, and I will comment this part because this is like quite a time taking part. So I have already saved the features matrix, and also I have saved the movie labels and these things like labels, the actual labels, and this is the dictionary. So this is the dictionary, this is the feature matrix, and this is the label, whether it is positive or negative. And now what are we doing? We are just putting it into stratified K for 90-10. We are applying SVM as model 1, multinomial naive Bayes as model 2. Okay, and we do it for all the 10 iterations, right? You will
Okay.
do it for all the 10 iterations, and then you will evaluate the confusion matrix and all. So you see total, see how much accuracy has come with SVM 80%, with naive Bayes 81.65%. With BAV or word model feature, you got 80%, almost 81%, or say you can say with naive Bayes 82% accuracy on this particular data set. So what it does, like out of 2000, it will keep say uh, 200 files for testing and the rest for training, and then again it will keep on doing.
Okay.
And after once everything is evaluated, it will tell the accuracy which has come 82% maybe for naive Bayes, and 80 or 81% for SV. Good enough.
Okay.
So
But how you split this total positive review file 1000?
how we
Split the total positive review file equal to 1000.
how we split the total review?
2000.
Huh.
Yes, total positive review
Yeah.
files.
So this thing we are worried about, like 2000 into 2500, right? See, when you pass
Mhm.
it in the model, when you do model 1 dot fit or model 2 dot fit,
Mhm.
so you are giving the feature matrix here as an extrain.
Oh yeah.
All of the 2000 you are giving here, right?
Okay.
All of the 2000 you are giving here, but you are giving the labels also, no? That first 1000 is 0. First 1000 is 0 and the second 1000 is 1. So by that you are actually separating. Got it?
Okay.
So you take any of the model which you have learned before, while um, any of the model you take which we have learned before, why what we will do? We will have a data set, IA data set,
Mm. Yes.
and then
Yes,
we
we
will
do.
have the features, 96 features from three classes. So what you do? You give the whole data set here, and you in the labels you will give like in 96 say first 33 is this, right?
Yeah.
And
Yeah.
second 33. So
Training and testing.
like that only they have done. The first 1000 files it is 0, then second 1000 it is 1,
Okay. Okay. Okay.
right?
Yeah.
So like that it divides, and yeah. But still this word count vector we have done which is also famously known as bag of word models. But still we have not
Okay.
discussed the TF-IDF features, term frequency and inverse document frequency. So but this word count factor or bag of word you can say it was very necessary and very popular also. Why I am saying necessary? Because it will build the foundation for the TF-IDF features. TF-IDF features are nothing but like what do you say? TF-IDF is nothing but like an advanced version of Bag word model. Okay. So
Mhm.
like that you can try running it. I will send you this this file. You can try running it, get the accuracies and all, and maybe if you wish you can go line by line also seeing what things are doing what. Okay, I have written the code from scratch. Everything I have written it in Python so that to make a clear understanding. Okay. Otherwise, it is also possible that I use some library where I can, calculate this dictionary and that whole stuff, feature extraction and all I could have done through some tool also.
Okay.
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 So so that is why you should also read about this. Maybe try to code something like this. But yeah, it will give you a clear understanding. So this is it about whole about word model, or you can say word count vectors. Maybe in next session on the same data set I will show you TF-IDF. Okay. We will talk about TF-IDF and then I will show you how we use TF-IDF.
Okay. It's fine.
Okay.
Okay.
So